Welcome to this class on building an automated ETL pipeline in Power Query. I am really glad you're here. It is the start of the month. A new workbook lands in your folder. The dates are written in 5 different formats. In fact, all the content are written in several formats. And you already understand the challenges that you have. There's something that you've noticed. This happens every time you receive the same or basically surveillance report. So what you need to do is not to clean this surveillance report every month it comes. So you can create an automated ETL pipeline in Power Query to ensure that once this file comes into your folder, all you need to do is to open your ETL, click refresh, and everything has been cleaned. So it makes your work easy and makes you productive, and basically may even land you that promotion you're looking for. So take a deep breath, get comfortable. Let's begin. Let's head on to the workflow that we'll be using in this class for now. So to assess that, we will click on Open Class Slides. So we will get the workflows and the queries that we have written for you to use alongside this class. So now, during Sprint 1, we will progressively build this workflow. That is, we are going to be importing the January data. We will inspect the data, then identify data quality problems. We will design business rules. We will build reusable functions and apply the functions to January so that we have a clean January data set. Notice something important, right? We are yet to introduce data in the folder. We are not talking about automation yet. We are not looping through files yet, because everything is focused on one workbook now, which is the January workbook. And that is deliberate because we cannot automate a process until we know the process actually works. Okay? So a question many beginners ask is, why aren't we importing all monthly files from the beginning? Because that will make debugging almost impossible, right? So that is our answer. That will make debugging almost impossible. So imagine importing 12 workbooks at once. If something goes wrong, which workbook caused the problem? Which row contains the error? Which transformation failed? We won't know. So finding the source of the problem becomes much more difficult. Instead, as a professional ETL developer, isolate one representative workbook. Then you understand that workbook completely. You solve every data quality issue within that workbook. Then test every business rule, right? Only after everything works perfectly do they scale, or will you scale that solution that you have created. So that is why January becomes our development data set. Our objective is to build a reliable ETL pipeline for one representative workbook. Every cleaning rule will be developed, tested, and validated using that one representative workbook, which is our January file or January workbook, before it is reused for future monthly workbooks. So notice the wordings carefully. We are not building functions for January, right? Or for the first file, whichever the first file is that you have. We are using January to validate functions that will eventually clean every month's workbook, right? So the January workbook is our testing ground, not our final destination. I hope you're following. Now that we understand why we start with one workbook, the next step is to bring that workbook into Power Query. At this stage, our objective is not to clean the data, right? Our objective is simply to import the workbook and prepare it so that we can begin analyzing its content. The disease surveillance unit receives one Excel workbook every month, like we have here in this surveillance folder. This is for January, this is for February, March, and April. Although each workbook follows the same overall structure, it was designed primarily for human viewing rather than automated data processing. So we have the January workbook open, right? So you see that this is an integrated disease surveillance report that is for cholera. Okay, so we have the case ID, the report date, the onset date, facility ID, and so many other columns. All right. Notice that the workbook contains a report title. You can see the report title in the first row, right? That title makes the workbook easier for people to read. However, it creates a problem for Power Query. Power Query expects the first row of a table to contain the column names. Instead, the first row in our data set now contains a report heading. So if we import the worksheet exactly as it appears, Power Query will treat that report title as part of the data. So as a result, the actual column names will not be recognized. You see, instead of the case ID, report date, onset, and all of these column heading, we are going to be having column 1, column 2, column 3, and so on. And every transformation we build afterwards will become more difficult. So before we can inspect the data, we must first prepare the worksheet by removing the report banner and promoting the correct header row. And that's what we are going to do with our first M query when we go into Power Query Editor. So let us go into or open a blank Power Query Editor from this workbook, or in fact, from any workbook or a blank workbook if you like. So we are going to head to data. Okay, you'll see get data, click and say we want to say launch Power Query Editor. Click on launch Power Query Editor. So we have Power Query Editor launched now. So our first ETL query will perform only the structural preparation of the workbook. It will follow these rules. Number 1 is going to import the January file or workbook. Then it will read the first worksheet. Then it will remove the report banner that we saw there. Then it will promote the first data row to become the column headers. Then it will return the prepared table. Let us do that. But before we do that, notice what we did not include. We are not cleaning the case IDs, the onset dates, and so on. So we are not fixing the dates or any other column, right? We are not standardizing the ages, right? We are not correcting laboratory results. All those activity belongs to later lessons. So for now, we simply want to properly structure our development data set. Inside Power Query now, we want to build our query. So we will go to new source, other source, then blank query, right? Here, we'll go to advanced editor, click on advanced editor. We are going to paste this query and explain it clearly, okay? Let's explain the blocks that we have here. So the first step now, walking through our codes, a file.content opens the Excel workbook from its location on your computer. In our computer, it is saved on our desktop in surveillance folder, right? And so we are going to correct this file name, right, with the file name we have here, line list. Okay, the easiest way you can do it is that you can right click on the file and then you say copy as path. Okay, you can easily just replace this path here, okay, because this name now varies, so you can replace that. Okay, so you can see that now. That's the easiest way to do that. It's in your computer. You just open the folder, right click on the file, then copy as path, and then you get that link to, or that path link to use there. Okay, so I said file.content here opens the Excel workbook from its location on your computer. This whole block, that is excel.workbook, open and close parenthesis here, reads the content of that workbook and returns information about every worksheet, table, and name ranges it contains, that workbook contains. The beautiful thing is this, that this is something you can reuse, right, in your own case. So that is why we are explaining this, to make you understand that this indeed is not difficult. So at this point, Power Query has accessed the workbook, right? but it has not yet selected any specific worksheet. And that is why we are here on the grid, right? The grid variable here, what it does is that it indicates that a workbook may contain multiple worksheets. So it's our understanding rather that a workbook can contain multiple worksheets. So the expression here, source in curly braces, 0 there, selects the first worksheet in the workbook, right? So the data in square brackets here extracts the worksheet as Power Query table. You understand? So although the worksheet is now available, it still contains the report banner and the header have not yet been recognized. That is why we have the variable remove banner, right? And we say table.skip grid, 1 in that parenthesis there. So the first row contains the report title rather than field name. Remember, we showcased that. So by skipping the first row, the actual header row removes the top of the table. The first row contains the report title rather than the field names, as we showcased earlier. So by skipping the first row, the actual header row moves to the top of the table. So this prepares the worksheet for the next transformation. So the next transformation will be to promote headers, right? Then we have the promote header variable here. So after removing the banner, the first row now contains the field names. So table.promote header here, convert those values into column headers. So the table now has meaningful column names such as case ID, onset date, report date, age, sex, date, outcome, and laboratory results. Unlike the generic names, or instead of the generic names like column 1, column 2, and so on. Then here in promote headers, the in statement returns a prepared table as the output of the query. So this table becomes the development dataset that we will use throughout the remainder of sprint 1. So now that we have explained that, if you have any question, kindly drop the question in your comment or in the comment, and we will respond to your question. But the beautiful thing about this is when we can look at this and understand it, then it will be easy to replicate, or it will be easy to use in whatever data set we want to use. So let's click on done. We have created that, and immediately we clicked on done. What happened? We have our January data set here. The reason you see this, you may not see this row in yours, is because on my view tab, I already have column distribution checked, column profile checked, and column quality checked. And this just gives me a summary of assessments, basically assessing each of the column, right? Looking at the valid entries, the errors recorded, and these errors usually are recorded due to change, right, in data type by Power Query, right? The empty shows us how many rows are empty, or the percentage of rows that are empty here. And if you scroll around or throughout the data set, you are going to see that this is dependent on the content of our columns. Okay, so if you have them unchecked, you wouldn't have that report. Okay, so professional ETL developers do something differently from beginners. They inspect the data, they study every column, they document every problem before attempting to solve it. So this stage is known as what? Data profiling. Data profiling is one of the most important stages of any ETL project because it helps us to understand the quality, the structure, and consistency of the incoming data. So we are working with healthcare data. So I would say you should think of a doctor. Before prescribing medications, the doctor first examines the patient, asks questions, requests laboratory tests, and identifies the underlying problems. Only after making a diagnosis does treatment begin, right? So ETL follows exactly the same principle. So before we write cleaning functions, we must first diagnose the quality of the data. Imagine this. that your manager asks you to clean the January surveillance workbook. This workbook we have before us now, or this data we have before us now. So one approach will be to start writing M code immediately, right? However, that approach has one major weakness. You don't yet know what problems exist inside the data. So some columns may already have been cleaned, others may contain multiple issues. So if we begin writing functions without first understanding the data, we risk solving problems that don't exist while missing problems that do. So professional ETL developers therefore spend time inspecting the data set before writing a single transformation. So our objective in this lesson is simple. And the objective is that we understand the data before we attempt to clean it. And understanding the data is quite simple. Yeah, there are various ways you could understand this data. Right now, writing a data quality assessment query could look daunting, right? So we are going to just hover through to look at what we have. But the important thing is this: as an ETL engineer or a data pipeline engineer, you should be looking at ways in which you understand how those data is gotten, how you get data, right? For instance, you look at the report dates here. So you see that one of the major challenge of the report date is that the date comes in different formats. And Excel converts some of the dates to Excel serials. Then you see that in the onset date, you kind of find the same issues. And you see the issues in the facility ID leading zeros, and you have some single numbers or digits instead. Okay. And you can see that the case ID arrangement of the IDs in the case ID is quite different from what we have in the facility ID. So the question is, are you going to harmonize these, or you're going to strip these to single digits, right? Then you look at the LGAs, look at the states. We have reverse, for instance, all lowercase. You have reverse title case. You have reverse uppercase, and so on. Similar with Lagos, Kano, and so on. Then the age, you can see you have 2 years. Then you have some in months, right? 10 months here. And you have this in 2 years. You can look at that, right? Then you come to the sex column. You have female and F for female, lowercase female. It's the same arrangement with male. Then the lab results you see. So the idea here is to look at the content that you have, then agree on a convention you are going to use for transforming this data into that convention. Okay, that is the idea there. Notice how our workflow is changing. We have imported the workbook, we'll prepare the data set, we'll profile the data set, and we'll identify quality issues like we just identified quality issues now. Then we are going to design business rules. Remember, I said, depending on your agreed convention, what are the correct standards you are going to be using. So you'll see the ones we use in this class. Then when we design the business rules, we are going to build cleaning functions. Okay, so every stage depends on the stage before it. We cannot design business rules until we know what problems exist, just like I was showing you within the data set. So we cannot build functions until the business rules have been agreed. That is why profiling always comes before cleaning and not after cleaning. Okay, so now at this point, an experienced ETL developer begins asking questions. For instance, for the case ID, okay, for the case ID now, the question an experienced ETL developer will ask include: should spaces be removed? Should punctuations, if present, be removed? Should every ID follow one format? For the dates, now, the questions may include: Which date format should become the standard? Very important. Which date format should become the standard? How should Excel serial dates be handled? You can see that Excel, we have some serial dates here, right? What happens if an invalid date is encountered? What happens if when we encounter, we convert this and we are having errors because not all of the dates can be passed, okay? Now, for the age column right, the questions may include, are months converted into years? Should unrealistic ages be rejected, right? It's important that we ask if months can be converted into years, because we cannot report months in the same category we report years, okay? So we may decide to convert all months to years. And again, when working with age, we need to be very careful, because within age column, we can have outliers. For instance, we can have impossible age or ages like those above 200, okay? So we should ask ourselves this question, that should unrealistic ages be rejected? Or how do we even deal with missing age, right? Like you can see here in situations where we have null. What you should notice is that we are not writing codes yet. We are defining business rules. So this will help you define what? Business rules. Professional ETL projects are driven by what? Business rules, not by programming language. So the code simply implements those rules you have created, those rules you have set. So before even jumping into data cleaning, the goal is to do what? Or to define those business goals, right? To look at the pros and the cons of decisions that you must take within that cleaning process. We can write a specific function, right? Or build a specific function to clean the case IDs or all the IDs, right? For instance, case ID and the facility ID may use the same function. We can write another or build another to handle dates, okay? To handle what? Dates. And that can handle any dates within our data set. So now, based on what we have now, we can do what? We can build one to standardize states, build one to standardize sex, standardize lab results, and standardize the outcome, right? And we can also standardize states, right? And from the standardized states, we can generate our region from those states, okay? So this becomes our ETL development roadmap. So instead of trying to clean everything at once, we solve one business problem at a time. Each completed function becomes another building block in our ETL pipeline. So why do we build small functions? Why don't we write one large function that cleans the entire data set? Because that will make the ETL process difficult to understand, difficult to test, and difficult to maintain. So professional developers will build many small reusable functions. So each function has one responsibility, so that if a business rule changes in the future, only the affected functions need to be updated, and the rest of the ETL pipeline will remain unchanged. So this modular approach makes the solution easier to test, easier to reuse, and easier to maintain over time. Let's build our first function. We go to our home tab, new source, other sources, then blank query. So in blank query now, we'll go to advanced editor. So in the advanced editor, or from the advanced editor, we are going to be writing our query, okay? Let's copy this query here. We have written it here for you to help with your studies. So this will clean the ID, okay? So let's copy this and go back there. So we'll paste it here, then we will explain it. Okay, let's explain that, okay? So the first step here is this line, okay? This line, you can see it, right? So every reusable function begins by accepting an input. Note that every reusable function begins with accepting an input. So the parameter is called input. We declare it as any because the function should be able to receive numbers, right? You see input as what? Any, right? We declare it as any because the function should be able to receive numbers
text, or null value. So the function returns a nullable number, right? It returns a nullable number, meaning the output may either be a valid number or a null. So that is what that does. Here, the variable s, what does it do? So the function first checks whether the input is null, right? That's why I say if input equal null, then null. Otherwise, the value is converted into text. That is why I say text from what? Input. Text from the input. Then we progress to the second variable here, which is no decimal. Some value may contain decimal points, for example, like 40.0, 18.5, and so on. So everything after the decimal point is removed. So this leaves only the whole number portion of the value. That is what the no decimal variable would do. If they result from a conversion here, that is what S means, equal null, then null. If it's null, then let it be null. Else, we have to get the text before the dot delimiter. Do you get it? Before the what? Dot delimiter. That's what that tells us. Then we progress to digits, right? We progress to digits. Okay. Now, in the digits now, we say this is where the actual cleaning happens. So text.select here keeps only the character specified in this case. And in this case, our character is from what? It keeps digits from 0 to 9. It keeps digits from what? 0 to 9. Notice that this is step by step. You see that no decimal variable here referred to the step above it, which is S, or to the variable above it, which is S. Realize that digit referred to no decimal. You see that we are taking it what? Step by step. The instruction is what? Step by step. So the next step will be the result.
So this result checks whether any digits were found. So if no digits remain, there is nothing to convert. So the function returns null. Otherwise, number.fromText here converts the extracted digits into a numeric value that Power Query can use for calculations. Let's go ahead and click on Done. Okay. Then we are going to rename that query so that we always know it. Okay, so right click on it and say rename. Let's say fn, indicating that is a function, and we call it, say, clean ID or extract number. Okay, maybe let's just call it clean ID so that we will know that function is to be used to clean ID. Then you hit enter. Okay. All right. So now we've created our first function, right? So what we can do is to test that function if it works well. And remember, that's why we say we are using this workbook as our development workbook, right? What will be most dramatic here to test for this clean ID is this facility ID. Okay, so I'll just go and add a new column, right? I will add in column, then click on custom column, right? And that custom column, I'll call it facility ID underscore C so that we can basically compare. Then now, this is where I will use the function that we created, right? The function that we created, and we say that function is equal to fn. So you see it here. You see fn. You see the function here that you created. So you can open this. I'll open parentheses, then open square brackets. You will see the columns from your data set here. So you can just enter that facility ID, then close the parentheses. You see. Once we click OK now, we will be applying that function we created to the column facility ID. So if we click OK now, you're going to see it. Okay. Now, this is the difference. You can see, right? This is the difference. Facility ID cleaned. So you can see it, right? You can see how it differs from the facility ID here. Okay. So we have tested that. Remember, this is just our testing workbook. Okay, so let's go ahead to create the next function. Okay, to create the next function, we go to home, we'll go to a new source, we'll go to other sources, then blank query. In the blank query, we'll now go to advanced editor, click on advanced editor. Now, in the other functions we'll be creating, I will just go ahead. There'll be no need for me to showcase this way, but this is how you will go ahead to do that so that we'll be fast, okay? While we create the functions anyway, we'll explain them so that you understand, okay? So let's take this out. Remember, we have created a support material here as slides for you to use with this video, okay, with this tutorial. So now we want to clean the date columns, right? So we are going to copy this, right? This is what we have written here for you. We are going to explain it so that it's easy for you to rewrite and apply. So let us paste it, then we will explain it. In fact, the explanation is already here when you look at this, okay? Each variable, what is meant to achieve, right? Basically, okay? So, but let us explain this now. Remember, the first line, input as any, we already explained that line in the previous function, and we use that line across all of the functions we will be creating, or we have created and will create in this class. So you already know what that means, right? So, but a little reminder this time. So you see that we want the function to accept one parameter called input. That parameter is defined as any here because it may receive a date time, number, text, or a null value. So you see what we are trying to do. We are trying to ensure that anything that comes with a data set comes into, or the function accepts that as input, or the function basically accepts that as input. So the function returns a nullable date, meaning that the output will either be a valid date or null. That is why you see as what nullable date. Okay, then this second step here is to handle null values. You see here, we say if input equal null, then null. This helps the function or our function to handle null value because the function first checks whether a value exists. If the input is null, there is nothing to convert. So the function immediately returns what? Null. This prevents unnecessary errors later in our ETL pipeline. Then we go to the third step, which handles existing date values, because sometimes the date has already been what? Imported as proper Power Query date. So in this case, no conversion is necessary. The function simply returns the existing value. Then we go to the fourth step, right? Which says else if input is date time, then date time.date. Okay. Some systems store both date and time together, right? Some systems store both what? Date and time together. You see the date and you see the time. Okay. So in many surveillance reports, only the calendar date is what required. So date time.date removes time portion and keeps only the date. Okay. All right. The fifth step, we say else if input is number, then date from what? Input. Excel does not actually store dates as text. Internally, every date is stored as a serial number. For example, you can have a serial number like 45660, but it's indeed 3rd January 2025. So if Power Query receives a numeric value, so the date
from input here, remember the date from our target is what? Input, the input within that specific cell or that column, right? So now it allows the function to work even when the dates are stored what? Numerically, because that date from converts the serial number. Look at this. This is where we are talking about. Converts the serial number into a proper date. Then we say else. We come here to define specific variables here now. So now we said our first attempt at conversion, because you see here, we are doing what? Conversion now. This time, in fact, let me go back again here. Here we say if it's null, let it remain null. Here we said if it's date, then let it remain the date. Then following, we said if it's date time, then let us strip off the what? The time and leave the date. Here we said if it's a number, if it's a serial number, convert it to the date of that serial number. Then now we have now come here in these blocks to now begin to give the conditions, because we know that there are several conditions that will make a date not to pass correctly. So now the S variable here that says S equal to text.trim, then we say text.from, that input, right? What that does is that it ensures that leading or trailing spaces do not interfere with date conversion, because the following variable, which is A, will want to begin to convert those dates. So if we have leading or trailing spaces, that may cause an error. So that is why you see our variable A here will say try date from text, right? And we are referring to S. You see S, right? Referring to S, which is this stage here, okay? Basically, it says remove leading spaces from that text if it is text, okay? Then let's try to convert that text now, right, into British format for dates, right? Into what? British format for dates. This is why we have this, into British format for date, okay? The function assumes that date follows what? The British format of day, month, and year. This is the format commonly used in many countries, including Nigeria. Okay, so the second attempt is the what? The American format. That is, if the British conversion fails, the function tries the what? The American format. So if A tries and fail, it moves to B, which is the American what? The American format. Okay, then C is the final safeguard. So as the final safeguard, that is where we have C equal here. As the final safeguard, Power Query attempts its default date conversion. So if all previous attempts fail, that's the function returns null instead of generating what? An error. This makes the ETL pipeline more robust when unexpected values are encountered. So you can see, right? You see that. Why did we think of it this way? Because from experience, we know sometimes when importing data, dates are passed correctly. Sometimes they are not. Sometimes we need, if you go to locale, to correct the dates, the errors. Sometimes when you use the UK time format, all will be passed correctly. Sometimes when you use the US, so we had to use these conditions step by step to ensure that we have a good conversion, right? So let's go ahead and click on done. We are done with that, and we will rename that query to think function dates, okay, so that we know that that is for dates, and hit enter. Like we tested the clean ID, I think we can go ahead and just test the date function in one of the columns. Okay, so let's go to add columns, custom columns. Then
We want to say date underscore C. So just to test it, right? Now we say equal to the function date. You can see that function here. Open parentheses, open square bracket, and let's just pick, say, onset date to test it. Remember, this is just our development stage. Close the parentheses and click OK. We are going to have that, okay? You can see we have the dates correctly passed and null what remained null. Null what remained null. Okay, so that is it. So let's speedily go ahead and create the orders. I think after date will be what is next? It will be age, to clean the age column. So let's copy that. Like I said, we created this for this class as a means to support you in looking at the queries and helping you explain them so that you can create them creatively or recreate them creatively and apply them. And the link to this resource will be in the description area. Then we are going to also attach the data sets there in the description. Then we are going to attach a challenge that will be a little bit different from the data set. So you have two data sets, the data set for your weekly project attached and the data set for practice. So the data set we use for this class will be your data set for practice. Then your data set for the weekly project, which we are going to give you 2 weeks to complete, will be attached there as well, so that you use it, face new challenges, and truly test yourself if you have created or recreated the queries correctly. And if you have any problem, you let us know. We are going to guide you. Let's go back to queries. So we go to home and we say new queries as usual. Okay. And let's paste our age query. So we have already talked about this, still the same. Then let us proceed to standardizing our input, which is S. You remember, here we said if input equal to null, then null, straightforward. Else, and now remember when I showed us the challenge we had within the age column. In the age column, we had some text, numbers and texts together, right? So here we said if input equal to input, then if input rather equal to null, then null. Else, we say the text dot lower, we want to trim text, right? We want to trim the text, okay? Because now, like I said, the function first checks whether the input is null, right? If a value exists, it is converted to what? Text. That's why we have text dot lower, right? It's converted to text. Leading and trailing spaces are removed. That's why you have the text dot trim, okay? Right? Trim is a text function. Lower is a text function. I think you understand how this is written now. All right. Then all characters are converted to what? To lowercase. So this standardization makes later comparison much easier. For instance, all months, years, and whatever you have them are standardized into exactly all lower cases, right? Remember, this is easy to write because remember, lower is what? A text function, hence text dot lower. Trim is a text function, hence text dot trim, right? And text is expected in that conversion. So we say text from what? The input. That's what we have in the cell or in the column. Then we have the next, which is to determine whether age is recorded in months. That's why we use what? Is months. Okay, that's why we use is months. This part of the function here determines whether the age has been recorded in months. It looks for keywords such as months or MO as we have it in our data set, as we
as we experienced earlier. So if either keyword is found, the function marks the value as what? Monthly age. Basically, this allows the function to decide whether a conversion is required. And the beautiful thing is, remember, look at this as we've been discussing, is what? Step by step, right? So the next step is what? Num text, right? Now, these labels here can be anything, just something that you should remember what it is. It can be anything. It can be A, B, C, D, E, F, as you like it, right? It's just, what which should do or what which is expected to do. So now we have num text. We said if X, remember X there is null, then null. Let it be null. X, else rather, text.select, you're selecting S. We want to select 0 to 9 and strip behind the delimiter. Okay, so basically the function removes everything except digits and decimal points. Okay, so this ensures that descriptive text does not interfere with later calculations. So the extracted text is then converted into number. Okay, that is why we have this now here. We say if num text, that is the step above, equal to null, or num text equal to with space, then let it be null. Else, number from text, num text, right? Will make text into numbers from what? From num text, from this stage, the stage above. Then we have the next one, which is years. Okay, we want to now deal with what? Years. Okay, so years now convert months into what? Years. Because we say, again, still dealing with null. We said if the step above returns null, then let it be null, right? Else, if is months, remember our stage of is months, then we said number.round. That is where we now perform the calculation. We said, let that number you find there divide it by 12. Then let us round it into 2 decimal places. That's why you have number.round. Then you have that number. This number, this NUM, is from the stage above that we converted text to what? To numbers. Remember, then we divide by what? 12 and round it to 2 decimal places. So hope you understand that. Then the 5th step, which is the result here now, helps us to validate our age, because we now say, remember, if the step above, which is years, is null, then return null. Else, if years, which is a step above, is less than 0, or years, which is a step above, is greater than 120, then return it as null. Else, return it as the what? As the years. That is as the outcome or the result or the output of this variable. So what does this mean? This means that, we want to put a guardrail, right? Any age less than 0 is going to the negative, right? Less than 0 is going to negative. Greater than 120 means that we have people older than what? 120 years. And we are saying that, what we should deal with is what? Between 0, because now if you're converting months to years, you'll be having 0 points, right? In the positives between 0 and 120. So that is what we are saying here. Okay. Now, I believe this is clear. If it's not, ask your question in the comment. And please, if you find this training helpful, do well to share it across your communities, your friends, so that we have as many people joining our community to learn. Okay, so let's go ahead and then click on done. When we click on done, as usual, we will do what? Rename these. Okay, when we rename it, we want to call it function age. Okay, we want to call it age, or should we call it CleanAge? Okay, CleanAge. Hit enter. Should we test it and see? Okay, let's test it and see. Let us go to add column right? Custom column, and our custom column, we'll call that age_c so that we know that it's a test of our clean age. Then we'll say function clean age, okay? Open parentheses, open square bracket. Let us pick, where's the age column? Okay, this is the age column within our data set, close parentheses, and then click OK. When we do, you're going to see it, our conversion here. Null remains null. We have 0.83 indicating that that value was recorded as months initially. Okay, you can see that, right? Now it will be easy for us to do our grouping. It will be easy for us to do grouping to report and say, okay, between this age and this age, this was the prevalence and this was the outcome, right? Basically coming to conclusion or designing interventions that will reduce mortality or mortality rate within a particular age group or within the population, basically. Okay, so the next we will be dealing with will be, let's look at that, will be age group, right? And that will just mean that we will be creating groupings or bands, age bands, to do what? To group our age. And this wouldn't have been possible if we had not cleaned our age column. So remember, this resource is attached to the description of this video. Okay, so let's go back there to Power Query, home, right? As usual, okay. Advanced editor, let's paste our age group, right? We already have an understanding of the first line. The second line will say if age is null, then null. That's our guard, right? Okay, then we'll say else if age is less than 5, then we want to have this label, which is a grouping as less than 5. If age is less than 15, then let's say 5. Now we are saying between 5. I hope you understand this, because if we say less than 5, then we have between 5 to 14, because less than 15 will be 14, right? Then we say else if age is less than 45, then we say from that 15, right? Because we say less than 15, that means 14 should be the highest here. Less than 45, it takes us back to what? To 15, right? 15 will be the lowest here, right? Then else 45 plus, that is above 45, that is after 44, so which is 45 and above will be grouped into this. So we can click OK, rename it, say function age group. Okay, you're free to name as you like. So hit enter, and we have created that. And if you test it, you're going to see that that works. Okay, but mind you, you're going to test it on the clean column, because if you test it on the column you have not cleaned, you are most likely to have errors, right? Let us go to add column, custom column. The rest, you can test them, so that will be fast. We will not have to test them. We'll just create and explain. You see already how you test them, but let's just test this one. Okay, then let's say age group, let's say age group. Then we'll say function, I think age group, open parenthesis, square bracket. We want to use that column we cleaned called age_c. Yeah, then close parenthesis, click OK. You are going to see our age group now, right? And this age group is text. Remember, we label them in quotes, so they are text. They are not numbers. Okay, these are text. Let us proceed to creating orders. I think we'll be standardizing the sex column, the lab results, the outcomes. So these columns now: outcomes, lab results, sex, age, and state. Those are the columns we'll be dealing with now. So we'll just create them. We will not have to test them. But so when we work on the folder to put these functions together and use them in the data set within the folder, you are going to see these outcomes already. So let's just speed up the class and create those functions. Okay, so let's go ahead and create those functions to standardize those other columns. So to standardize text, we are going to explain this as well. But by now, really, you must have basically cracked the code to this. You already know this, what this line is, right? Then this let is the standard. You just say let. It's just like you're speaking English in English. Okay, let this be this, let this be this, let that be that. In what? In result. So it's just straightforward. So now the variable s, you say if impute, this is just a guard, right? If impute equal null, then let it be null. Else, we want to do what? To trim all text to lower. That want to basically convert all text to lower text, text. That's why I would say text dot lower, right? But we don't want any issues in our conversion. So we have to trim the spaces in our input. That's why I say text.trim. And we create another variable called result. We said if x, yeah, this our output from here equal to maybe like m, remember how it looked, right? Or s equal to male, then let it be m, because our agreed conversion is that let all male be represented with an uppercase M. Then we say else if S, that is the output above, equal to F, or S equal to female, then let female be represented with uppercase F. Else null, that is if. It's nothing around this, let it return null. So that is just straightforward and it's simple. I believe you will find this interesting. So let's click on done and rename this and call it function standardize sex. So the next will be what? I think that should be it. Okay, so let's go there. So the state now, first of all, we create a variable key, as usual, our guard, right? And again, as usual, we removed delimiters, right? The space delimiter, we removed the period delimiter, because why? In state, remember some state was f.c.t representing fct, right? So we already knew that we had to remove that dot so that we don't have any issue with conversion. So you understand this already, absolutely. Then we created a map and say, okay, where you see Lagos lowercase, we mean Lagos. Where you see Kano in lowercase, we mean Kano. You see Rivers in Rivers, we mean Rivers. Do you know why we can boldly? Because then, remember, we had Lagos, uppercase, lowercase, and so on. But because we had converted everything to lowercase within that column with our key above, right, it makes it easy for us to just make a map easy to say, okay, yeah, we actually have these states. These are the states that we have within that column. All right. We have stripped everything to lowercase. All right. So we want to have them in proper cases or title cases, as the case may be. So as title cases rather. So if lowercase Lagos, let it be a proper case Lagos and so on, as you can see. Then we say result equals to if key, that is the first variable, equal null, then let it be null, right? So here, else if record has field, then map comma key, then record dot field, map comma the key. What this does is that it first checks whether the lookup key exists inside the record. If it does, the corresponding standard value is what is returned. That is what it does, okay? That is just good to go. Now I want to clarify or explain that map here, this map here is what a lookup. It's just a small lookup. So not every possible Nigerian state appears in our lookup record. So if the state is not found, the function assumes it's already a valid state name and simply formats it properly. This allows the function to handle recognized state names without requiring every state to be listed explicitly in the lookup record. So let's go ahead and click done, and we will rename this to function standardize states. So the next is outcome, right? Yep, let's copy that. So let's paste that. Remember, in our outcome column, we had things like A for alive, uppercase A for alive. We had D for dead, died, and so on and so forth. So, and this is very simple. As usual, if input is null, equal to null rather, then let it be null. Else, we want to convert that to lower case what? Text. Then trim spaces or blank spaces around the text to prevent error in conversion. And we say if S now equal to alive or S equal to A, then let it have alive instead. If else, if S equal to dead or S equal to died or S equal to D, then dead. So you see now, this is why it's important to look at your data set so that you know the conditions to use so that it covers every angle, okay? This is very simple and straightforward, I believe. Let's rename that to function standardize outcome. What is left is lab result. Yes, we have lab result. I think then we have states from region, and that will be all. So for lab results, remember we still saw it. So basically, this has exactly the same. So you find that this is not as terrifying or as daunting as it has been perceived to be, right? And we believe that what we have done now will guide you into creating something substantial and will help you enhance your creativity in handling data cleaning most proficiently. So you see, this basically is exactly how we dealt with what standardizing what the outcome. You look at that, I believe you understand. If you don't understand, please let us know. So click on done and let's rename that to what? Standardized lab results. Hit enter. We have that now. So let's go to the last one, which will be the region from states, and we will explain that. Now we have map here. We say let map here, Lagos, Southwest, Kano, Northwest, Rivers, Southwest, FCT, North Central. So rather than writing a long series of if-else statements, we store the mapping inside a record. So let's think of this record as a small lookup table, right? Whenever Power Query receives a state, it simply checks whether that state exists inside the record. If it does, it returns the corresponding region. So this approach keeps the code word compact, smaller, readable, and easy to maintain. So if another state needs to be added later, we simply do what? Extend the record instead of rewriting the entire function. Let's say we had another state from maybe south east. So we have a southeast state added. We just come to include a southeast state within that map record. Okay. Then here we said if state is null, then null. That means if no state was supplied, there is no region to do what? To return. That is, if that column or that cell within state is null, then no region should be what? Returned. Okay. Then else, if record has field, that area, say first record.has field, checks whether the supplied state exists in the lookup record, right? Record.has field here, check whether what happens, check whether the supply state exists in the lookup record. If it does, record.field retrieves the matching what? Region. If it does, record.field what? Retrieves the matching region. So that is how this works. Let's click done, right click, rename, and call it what? Function region from state. Remember, you can name it as you like. Up to now, we have built and tested functions on a single workbook, right? That workbook taught us the rules. So now we point those same functions on at an entire folder and let Power Query clean every month for us. So this is where the pipeline starts to feel real, because we build it once and it runs on its own. So we start a fresh query, okay? And to start a fresh query, we have to go to home, new source, and we are bringing in a folder, right? So let's pick a folder, right? And say it's surveillance, this folder, okay? So let's bring that folder in. So we have 4 files here. Now, we don't want to combine and transform. We want to do what? We want to transform. So we will not click on combine and transform. We just want to do what? We just want to transform. So basically, clicking transform keeps us in control. We see the list of the files with their content and their names, and we decide what happens next. So before we go on, we tidy the list. So let's click on transform, right? As we click on transform, we have them here. Like I said, before we go on, let's tidy the list, right? So like now here, you see on the name column, we have the right list. But sometimes, right, on this name column, sometimes you see some files appearing with, say, funny marks like that, right? So what happens is that Excel have some temporary log files like that. So what happens is now you click the drop down, select your main files and click OK, okay? But in our case right now, nothing has happened like that, okay? So each row in this list is still a whole workbook that is not opened yet. You can see it, right? It's a whole workbook that is not opened yet, okay? Let's go to add column. We want to click on custom column. So in the custom column, let's call this custom column data, okay? And we remember when we're bringing in that other sheet, in the one we have in query 1, remember we had to remove the banner, so we had to promote headers, you understand? Let's do that here now for this. So we will say table dot promote header, okay? Yes, just click to enter, open parentheses, hit enter, table dot skip. Okay, we have it here. Click to enter, open Excel dot workbook and click to enter, open parentheses, square bracket, let's say contents. Now, if you look at it, when you scroll, you see that we have content there. So content, that's where the content is coming from. That is when you scroll to the left, the first column is content, okay? Comma, null, comma, true, close parentheses, open curly braces, 0, that is the first sheet. And in that first sheet, let it bring it as data, just as we explained in that first sheet that we did, and comma 1, close parentheses, comma, hit enter, open square brackets. Let us promote, say promote all scalar equals true, close the square bracket. We can go ahead now and close the parentheses, okay? So for every file, it opens the workbook, reads the first sheet, removes the report banner, and promotes the correct header row. You get it, right? Just as what we did in the sprint 1, that is, use that first sheet when we brought in that first sheet. So let's go ahead and click OK. Oh, it had an error here. It's a table, we click, when you are clicking to enter, you see it's a table. When you're clicking to enter a function, when typing, make sure you check. So here I'm going to remove that double table, hit enter. The same thing happened on table skip. So we click this to expand and look at that. Yep. I think when we typed and we entered, let's check again where that any of that those mistakes there. Hit enter. Yep, we've got it now. So you see right here, we have that column, right, that reads our workbook. So what we are going to do now is to expand the file. So we only need two columns. We need the data, which holds each prepared table, and name, which tells us the source file. So what we are going to do, let's select name and hold down control and select data. So you can see both columns are what highlighted now. So you can right click and choose. So let's right click on anyone and choose remove other columns. So that is possible in Power Query. You can either remove the columns you've highlighted or remove the other columns apart from the ones you've highlighted basically. So click on remove other columns. You see we have the name and the data. Okay. Now that we have just focused on the ones that we are interested in, what we can do now is that we will then click to expand the expand arrows on the data, right? You click the expand arrow on the data, you see all of the columns, right? You see all of the columns. Let's untick this use original column name as prefix, because if we leave it as original column name as prefix, what we risk is that it will be data dots, and we don't want that. So let's remove that and click on OK. And then you see the expansion, right? So do you know why we removed the other columns that were not necessary, and we left names and data? If we had left the other columns, it would be a long list of columns, because they will be here as well. You can see this is from case ID to the last, which is nodes, where data columns that from our imported from our data set. But you see names here, it just shows us what the label from our file, that is our file label. Now, basically what happens here is that you have all of our data, that is January to April, basically combined, stacked as there should be. What we are going to do now is to apply our functions. We'll be applying our functions, okay? So for each raw column, we are going to add one custom column that calls the matching function, right? So that means we are going to do for case ID and so on and so forth, right? So for all of these columns, applying all of these functions. So what we will do now is simple and straightforward. We are going to go to add column, add custom column. And for each of these columns we'll be cleaning, we'll call them clean columns. So let's call this case ID underscore C, so that will represent clean, right? So now we'll use this function for clean ID, okay? Open parentheses, open square brackets, and we want case ID, right? Close parentheses. Once we do that, we click OK. You see that we have the case ID clean column now, okay? Now, you see this was the original one. So let's proceed to what report dates now. You know, we had created the function to clean the dates column, right? So let's go to add column, custom column again. So that will be report dates, report dates underscore C for clean, right? So say equal to the function clean or function dates, okay? This one, open parentheses, square brackets. So you can basically click here and say insert, to insert it there, close parentheses, okay? Let's correct that, yeah. And then click OK. You have the dates now cleaned, okay? So the next is onset dates. Let's add a custom column. So onset dates underscore clean or C. for clean. Then we will apply the date, still the dates function we created on the column onset dates, and click OK. We have that as well. Okay, the next is facility ID custom column, and then say facility ID underscore C. The facility ID, we are going to apply the clean ID function we created, open parenthesis, square brackets, facility ID, close parenthesis, just like this. Simple, right? Click OK, and we are going to have the facility ID cleaned. So these 4 columns so far has been cleaned and thoroughly cleaned too. We are going to confirm. Then the next one is what states from what we worked on. So now let's proceed to standardizing states. So we are on add column, click on custom column, then we say states underscore C for clean. So function standardize, it will have a list of it here, standardized states, open parenthesis, square bracket, okay, close parenthesis. You see our states cleaned as we want it. Okay, the next will be age. So let's add a new custom column, say age underscore C for clean. And now let's apply our cleanAge function, open parenthesis, square bracket. We are applying that to age, close parenthesis, and apply that. Okay, you see it as applied as we tested previously. Then after age is sex, let's add a custom column for sex clean. So say sex underscore C for clean sex column. So we want to apply the standardized sex. We'll say equal the function standardize and pick it. I think this standardized sex, yes. Open parenthesis, square bracket, and let's pick the sex column from our data set, close parenthesis, click OK. So you can see it as we wanted it, right? Female, male, 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 female, just like that. So it's simple, right? Click on custom again for the next one. I think the next one should be what? Let's see, lab results. So custom column to create lab results cleaned. Let's apply that function for standardized lab results, open parenthesis, square bracket, then the lab result, derives the raw lab results column, then click OK. You see lab result cleaned very well. Then outcome, I think the next will be outcome. This one, this messy one, let us clean that. So let's add a custom column. We'll name that custom column outcome underscore C. Then let's call that function here for standardize outcome. Let's select it, open parentheses, square brackets, and we want the outcome column from the raw, yeah, this one, close parentheses, click OK. You see our outcome is alive or dead. Okay, the next is region from states, right? That is it. So custom column, so say region underscore C to represent clean. So call that function says region from state here. Remember when we created it, open parenthesis, square bracket. Let's pick state cleaned. Pick the cleaned column for state, not the raw one. If not, it will not have clean conversion. So let's click OK. You're going to see it now, Southwest and so on. Now, what is the difference between how we created regions from state in this class and how we did it in the last class? Put it in the comments. Remember to subscribe and share so that we get as many people to learn. So put in a comment, put your question in the comment as well. Remember, resources, the data set, and your project data set will be attached to the description of the video, as well as the first pinned comment in the comment. Okay, so do well to practice and send your project in for grading. So our messy columns have done their jobs. So what we are going to do now is to select every original column and right click to remove those columns, right? The ones we call our messy columns, right? Say original. So since they are basically close to each other, I can just click the first one, hold down my shift, right? Hold down that shift and go to where the clean case ID starts. So it ends in notes. You see, I held down shift and it highlighted everything. And I can just right click and say remove columns. So you see that all the messy columns are gone. We only have the clean column exactly as. So we can basically rename everything and remove the C's that we have here. For instance, just double click here and remove the C so that we just have case ID. Then region was the last column here. Okay. So now what we are going to do now is to set each column, that is to set the type on each column since custom columns arrived as any. So give number types, dates as date types, and text as text type, right? You can see right now, you see everything that we have is as any, right? You can see any, okay? So we can just make this case ID is text. We rather whole numbers, we can maintain them as whole numbers, right? Report date is date, so let's just put them as date. Okay, you see onset is date. Facility ID is whole number. State is text. Age is, let's use decimal because we had decimals there. Then sex is text. Lab result text. Outcome is text. Region is text. Okay, region is now text. So the table is now clean and consistent as well as complete. Okay, so we have it as connections already. So only create connection, right? And click OK. What I would like to do is that I would like to see how we can automate this. So originally we had January, February, March, and April. So let us add the same data set for May and June comes in, and we'll now test the automation. So we will not have to repeat this process again. We have 2 more months to add here. So that is for May and June, right? So now we are going to test what we have done, whether it's going to automate it. So here's the moment we have been working towards. So we have saved that month into the folder. We want to go back to the query and press refresh and see what happens. Okay, so we had the query here. Okay, this surveillance. Let's just double click to open that. Okay, so it's opening. Okay, so now the moment we've been waiting for, let us click refresh and see what happens. So you see, automatically we have, we had 4 months, that's January, February, March, April. You see, we have May now, and you see May have been cleaned exactly as we had orders. No additional column, right? You can see, and that is why we let this name here so that you will see the difference. You can also see the dates, right? May has been added. You see June has been added. So you see June has been added, right? So basically, when data keeps coming to that folder, all you need to do is now to click refresh. All you need to do is to click refresh. Everything that we have done will automatically, you see, in few seconds, I think it was less than about 2 seconds, you see that cleaning is applied. So congratulations, we have achieved that. So one rule you must keep: the automation trusts the shape of the data. So every monthly workbook must share the same layout, one banner row, then the header with the same column names. So once you do that, everything will clean clearly. Okay, so congratulations. See you in next class.